Hello, good day viewers. We have already learned how to evaluate sigma notation. So today we are going to apply that idea in evaluating definite integral. So we would like to evaluate the integral of the function x plus 2 with respect to x from 0 down to 5, taking n equal to 40. Remember, in Riemann sum, n stands for the number of rectangles inscribed under the curve. So what is the formula? The formula which we have derived earlier in our previous lesson is A, which stands for the area, equal to the summation for which k begins with 1 and stops at n of f of A plus k multiplied by dx, then multiplied by dx again, for which dx is the base, the length of the base of every single rectangle. K stands for 1, 2, 3 up to n. That is for n equal to 40. Then A is the lower limit. So let us define some terminologies here. Remember that dx can always be obtained by taking the difference between the upper and the lower limit, then divide by n, which is the number of rectangles. So this is equal to the upper limit, which is 5, minus the lower limit, which is 0, divided by 40. And if you simplify this, you're going to get 1 divided by 8, which means that the base of every single rectangle is 1 divided by 8. Then what again? We know that A is the lower limit, which is 0. Then K is there. So let us simplify or substitute. A is now equal to the summation for which K begins with 1 and stop at 40, which is our n, of f of what? A, which is 0, that is the lower limit, plus k times this. K times dx. Dx is 1 over 8. And 1 over 8 times k will give us k divided by 8. Then multiply by dx outside, which is 1 divided by 8. Let's further break it down because we can see that 0 plus this is still this. So A will now be equal to the summation k from 1 down to 40 of f of k divided by 8 multiplied by 1 divided by 8. We're almost done. What is f of k divided by x? Remember that f of x is given as x plus 2. So all you have to do is to substitute wherever you have x with k divided by 8. So this is equal to the summation for which k begins with 1 and stops at 40 of what? The whole of f of x plus 2, that is k over 8 plus 2. K over 8 plus 2. Remember, we still have 1 over 8 outside. Let's continue to the other side. So we take this, we distribute over here. We have k over 8 times 1 over 8. That will give us k over 64. So our area is equal to the summation k from 1 down to 40 of k over 64, then plus 1 over 8 times 2 is just 1 over 4. 1 over 4. Okay. Now we are going to break this summation into two parts, this and that. But since we are dealing with k here, for the first time we can factor out 1 over 64. So this is 1 divided by 64, then times the summation of what? Just k, for which k begins with 1 and stop at 40, then plus the summation of that constant, which is 1 over 4, from 1 down to 40. So this is a constant. If you have a constant, just take upper limit, multiply by that constant. We have dealt with all of this. But if it is a variable, you take what? N times n plus 1, then divide by 2. We have all of this in our previous lesson. So this is 1 divided by 64 multiplied by the whole of, if you simplify this, you know it is going to be n times n plus 1 divided by 2. But n is 40, so it will be 40 multiplied by 40 plus 1, that is 41, then divide by 2. But for the constant, just take the upper limit, that is our n, then you multiply by 1 over 4. So that would be 40 divided by 4. Take your calculator, simplify the whole of this. 1 over 64 times 40 times 41 divided by 2, you're going to obtain approximately 12.8. So this is 12.8. Then plus 40 divided by 4 is 10. If you add this together, you have 22.8 approximately in just one decimal place. So this implies that the area under the curve between 0 to 5 of the function x plus 2 with respect to x, taking 40 rectangles, will give you 22.8. But let us find the exact area and compare it with this one. You see, in this tutorial, we have used n equal to 40, but subsequently I will use the same example but take n as it approaches infinity to see, because I told you, the more rectangles inscribed, the more you're being closer to the actual area. So now let us find the actual area and see whether it is closer to this one or not. To find the actual area, we're going to integrate this, then apply the limit. If you integrate x, you're going to get x squared divided by 2. If you integrate 2, you're going to get 2x. Then you apply the limit from 0 down to 5, as simple as that. Plug in 5 here, you have 5 squared is 25 divided by 2. Then plus 5 times 3, this is 10. Can you see that? This will give us 12.5, right? This is 12.5 plus 10. And this will be 22.5. Can you see how close the areas are? Very close. The only difference is 0.3. So subsequently, we are going to take as n approaches infinity to see whether we are going to get this one directly. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.